Okay, so today we're going to talk about polynomials. What is a polynomial? Have I seen a polynomial before? When I've seen a polynomial before, assuming I've seen a polynomial before, did I like the polynomial? And did I understand the polynomial? These are good questions. I've got a few more here as well that we want to consider, but let's get right into it. So, what is a polynomial? Great question. Glad you asked. A polynomial is a function of at least one term with only non-negative integer exponents. What does non-negative mean? Excellent. That means 0 or greater, right? What is an integer? Good answer. Anything that's a whole number, right? So integers include positive and negative whole numbers, but in this case, we're only talking about we want non-negative integer exponents. So when we look at this lovely example that I've provided here, I see that I have an integer exponent of 4, an integer exponent of 3. Those are not negative. And although it is not written here, we could think of this as x to the 0 power because it's just 10, right? So 10 times x to the 0 power is still just 10 because anything to the 0 power is 1. Okay, great. Now, one thing that came up in this definition was we saw this word term. What's a term? Great question. Terms, groupings of numbers and variables separated by addition or subtraction. So when I look at this example here, this example has 3 terms. Good. Leading coefficient. So what is that? That is the coefficient in front of the term with the largest exponent. So the leading coefficient for this example would be 7 because that is the coefficient number in front of the term with the largest exponent, and 4 is the largest exponent. Degree of a term, that is the exponent. So each term has its own degree. So this is degree 4, this is degree 3, and remember this was x to the 0, so the degree was 0. But we don't care as much about the degree of each term as we do the degree of the polynomial. So the degree of the polynomial is the largest exponent. So in this case, that is going to be our 4. So if we go back here and we start to label things, I know that the leading coefficient was 7. There were 3 terms. We looked at the degree of each exponent, but the degree of the polynomial is 4. And then the last thing is the standard form of a polynomial. So the standard form of a polynomial is when the terms are written in order from highest to lowest exponent or highest to lowest degree. So this polynomial here is written in standard form, 7x to the 4th minus 9x to the 3rd plus 10x to the 0 power. So we're going from highest, 4, and then 3. There's nothing to the second power, nothing to the first power, and then to the 0th power. So that is a polynomial in standard form. That is our definition of polynomial. And these are key vocab words that I will be using, so we want to make sure we understand. Okay, now I want you to identify which of these are polynomials and which of them aren't. So I want you to take a minute and do this. Again, think about our definition. At least one term with only non-negative integer exponents. So I want you to pause the video, identify which are polynomials and which aren't, and unpause when you're ready to discuss. Okay, so these are the polynomials on the left, and these are not polynomials on the right here. So let's just look real quick at the polynomials just to verify that they meet our definition. I've got more than one term. Each exponent is a non-negative integer. Each exponent is a non-negative integer. I've got more than one term. Each exponent is a non-negative integer. I've got more than one term. Here, this is okay that we have a square root because it's on the number or the coefficient, as opposed to if this was on the variable, which we'll see here in a second, this would not meet our definition of polynomial then. And I will explain that when we talk about this one here. I would also point out this polynomial is not in standard form, but it's still a polynomial. Okay, great. So now let's identify what makes these other ones not polynomials. Here, we have a negative exponent, right? Not a polynomial. Here, I have a variable that is an exponent. A variable is not an integer. It can be an integer at times, but it's not always an integer and not always non-negative as well. Here I have a non-integer exponent, so that's causing a problem. And here I have the root on the variable. Now, again, why is a root on a variable a problem? Well, we may or may not remember from a previous course that the square root of x is the same thing as x to the 1/2. Now, if you don't know that, or if you haven't seen that before, or if you don't remember, that's fine. Just keep in mind that when we're talking about polynomials, we can't have roots on variables, okay? So that's, for right now, that's what you need to know, is recognize, okay, I have a root on a variable, therefore that's not a polynomial. It's still a function, it's just not a polynomial. And then the last one, let's go back to our fun highlighter here. We have a variable in the denominator. Why is that a problem? Why, that's a good question, because, right, this still has an integer exponent. This would be 5 over x to the first. Is that a problem? It is a problem. Why is it a problem? Good question. So again, this may or may not be something that you know or have seen or remember. Maybe you've seen it, but you don't remember. But if I have, so in this case, let's just use what we have. So 5 over x, this is the same thing as 5x to the negative first. So whenever we have a variable in the denominator, that is actually considered a negative exponent in the numerator. Just to give you another example, if we have, and I'm just going to stick with the 5, that part doesn't matter, 5 over x squared, this would be 5x to the negative second. And just to show you also up here where we had the 3x to the negative third, this is actually 3 over x to the third. So again, this part here you don't totally need to know right now if you don't remember that or haven't seen it before, but what you do need to know in terms of polynomials is if there is a variable in the denominator, that is not a polynomial. Next thing I just want to point out, and hopefully we see this back here as well, right? This is a quadratic function. But I want to point out, because we've been dealing with lines and quadratic functions so far a lot this year, that lines and quadratic functions both meet our definition of polynomials. They are just specific polynomials that we use and deal with a lot, so they get, kind of their own sections as well, but they will still show up in the polynomial unit because they are still polynomials. Polynomials just cover more than lines and cover more than just lines and quadratics. So again, conclusion, what is a polynomial? It is a function of at least one term with only non-negative integer exponents. That's what we want to take away from this. So here we just want to be able to identify, is something or is it not a polynomial? Nice work.